There are three objectives of this experiment. First, to satisfy Coulomb's law experimentally. Second, to study the parameters that affect the electric force. And third, to find experimentally the electric constant K.
Hi, my name is NURFARAH binti Muhammad FAIZU. Just now, my friend has already tell you about the objective of this experiment. So, now it is my time to tell you about the theory of this experiment. Let's go! It's the theoretical background about the Coulomb's law. Coulomb's law is the magnitude of the electric force that a particle exerts on directly proportional to the product of the charge and inversely proportional to the space on the distance between them. Mathematically, the magnitude of the electrostatic force, Fe, acting on two charged particles, Q1 and Q2, can be expressed as this formula. E is equal to K multiplied by Q1 and Q2 divided by R squared, where K is a constant for the Coulomb's law and R.
The value of charge in our experiment is -2 microcoulomb for charge 1 and 6 microcoulomb for charge 2. The distance between the two charges are changed from 10 cm to 3 cm, and the force value for each distance is recorded. And finally, this is our result. R squared and 1 over R squared are also recorded in the table.
For the analysis part 1, we use Excel software and we plot the graph related to Fe and R. What can I comment from the graph is Coulombian's law equation, which is Fe equal to K multiplied by Q1 and Q2 per R2. Based on the graph, it will get the exponential graph because Fe and R2 not directly proportional. Second, we need to plot one more graph relates to Fe and 1 per R2, which means we use Excel, and from the graph we find the electric constant, which means K.
First, we need to find the gradient of the graph, which means y2 minus y1 per x2 minus x1. So we get the m, which is 0.1079. To find the electric constant, we use the equation gradient or m equal to k multiplied by q1 and q2, and we arrange it with k equal to m q1 and q2, and we got k is 8.99 multiply 10 power of 9. Third, we calculate the percentage error in k, and which means we know k known are 9.0 multiplied by 10 power of 9 mn square per c square. So we took the k known minus the k we get, and per the k known, calculate that and multiply by 100%. So the percent error we get is 0.1%.
Assalamualaikum, I am Shamimie and I will present for Coulomb'S Law Part 2. I will start explaining the method of Coulomb'S Law Part 2. Firstly, the PET simulation was opened. Secondly, the charge Q1 and the distance R values were fixed at 5 microcoulomb and 6 centimeter respectively. Thirdly, the charge on object 2, which was Q2, was changed to 3. The electric force between two objects, Fe, was recorded. Step 2 until 3 was repeated, and the value of Q2 was changed to 4 until 10. And result. As you can see, this is the result that had been recorded in table 2. And this is the graph from data analysis. As you can see, the electric force between two objects, Fe, is directly proportional to the charge on object 2, which is Q2. This is the question that had been answered by me. That's all from me. Thank you.
Okay, for discussion, we can say that there are two things that affect the electric, which are the distance between the particle charge and the amount of the electric that they are carried. Okay, before I end this video, I would like to conclude what we get from this experiment. First one, this experiment satisfied the Coulomb's law. Second one, the parameter that affect the electric is the distance between particles and the amount of electric charge that they carried. And the last one, the electric constant for this experiment is 8.99 multiplied by 10 to the power of 9. So guys, that is the conclusion for this experiment. Okay, so that's all from us. Thank you for watching. We hope that you like our video. Please stay safe and stay home guys. Hashtag kita jaga kita. Hashtag UATM di hati.